Jeff Parshley will introduce himself. He's a lead at SRK and the co-facilitator for this session. Thanks, Jeff.
Yeah, but don't time me. I get more than 5 minutes. No, I will take much less than that. My name is Jeff Parshley. I'm really glad that we could actually all be here in person. I think all of us have had 2 years of headaches and nightmares and frustration. So it's nice to see people, actually see faces. It's been 2 years we've had to put this off until we could get together again. So I'm glad to see everybody. There's been a lot of progress made as Tani and others talked about in the first session. So it wasn't a wasted 2 years, and that was great. But it's, as you know, and Ann said initially, the whole point of this is really dialogue. I mean, that's why we're not doing long presentations. We're really trying to get the dialogue going. And as you saw in the first session, it worked really well. And we hope to continue that through the whole day. So this next session is really sort of our broad session. We have people from industry, we have consultants, NGOs, government, academia. We have a little of everything here, and this is sort of a open-ended session with people, these individuals bringing particular perspectives or ideas for the discussion part that we're going to bring up. So we have Jeff Mock, who is from the United States Geological Survey. We have Jim Gusick, who actually both Jeff and Jim jumped in on some of the questions in the previous session. Jim is with Lincoln. He's an expert in particularly passive treatment methodologies. Oh, and then there is Ginger McLemore, who also is, you guys all heard from earlier in the last Q&A. She's with the New Mexico Institute of Mining and Technology in Socorro, New Mexico, and a professor there as well. We have Jason Willis. He's attended all of these, haven't you, Jason? I think every one of these summits. He's from Trout Unlimited. He's the boots on the ground guy. He's got some great examples. He's been the guy who's actually making this stuff work on the ground and developing partnerships. So I look forward to hear what he has to say about that. And then we have Travis Snyder from Sonora Copper, and Adam Hawkins as well. They are in the process of a brownfields redevelopment on a mine site here in Arizona, the Cactus Mine. And then online, we have Carrie Monahan, who's actually submitted some comments earlier to us. She works as the Sierra Fund Program Director out of Northern California. And so that is an organization that designs and directs research to fill critical gaps in ecosystem and community resiliency programs. So she's done a lot of work with AML sites, particularly some of the gold rush type sites in California. So I'm going to let each one of them, if they have something else they want to say about themselves, I'm going to open that up, and we're going to start with Jeff.
Thanks very much, Jeff. Just for background, I want to underscore the fact that I worked as an exploration geologist, a mine geologist. After I finished my PhD at the University of Michigan, I taught economic geology at the University of Auckland in New Zealand for 19 years. I led their mineral deposit research group, and in 2012, I came back to join the United States Geological Survey in Denver. So I've worn a lot of hats. My presentation today is about quantifying abandoned mine lands in the United States. My co-authors are all working with me at the USGS in Denver. This is a fantastic group of people. If you talk about collaboration, people that have different talents, this is a great example of that. All of our databases are available online. Our project is called USMIN. You can either get that off our website, or if you use ArcGIS online, you just put in USMIN and our databases come up that way. We have two main streams of work. One is getting information on the most significant mineral deposits in the United States. That's our mineral deposit databases. And the other one's these mine symbols from USGS topographic maps. Here's a topographic map from Crested Butte. Andy Manning is going to recognize this. It shows features like prospect pits and adits and mine shafts. And we have a team of people that have gone through these topographic maps and have digitized these mine symbols to make them available in an ArcGIS database. There are 52 feature classes that we found so far. And we have completed all the conterminous US except for West Virginia, New York, and Pennsylvania. Pennsylvania is now in review. 92% of the data reside in 8 feature classes, and we can subdivide those into things that either relate to coal and hard rock mines or industrial minerals. Coal and hard rock, we can't pull apart on the basis of the feature classes because you can have an adit at a coal mine or at a hard rock mine. Same with the shaft. We're really fortunate to be in Colorado because we've worked really closely with state and federal agencies there on their previous work. And when we do the numbers, they come out pretty similar. Colorado Department of Public Health and Environment came up with 23,000 abandoned mine land physical hazards in the state of Colorado. The US Forest Service worked with the Geological Survey, and they said there's more than 20,000 abandoned mine related features in the state of Colorado. And our topo data gives us something between 17,000 and 40,000. Now we know that the topo data aren't perfect, but it's reassuring to us that in a first order look, we're all on the same page. We're all pretty close. And pretty close, when you don't have a better answer, is pretty good. We call this our 1,000 points of light slide. It's actually sign of the devil, 666,000 points of light. That's where the mine features are in the United States. The next slides are going to break those down into those 8 feature classes we talked about, so that you get an idea where the hard rock and coal mines are on the one hand and the industrial minerals on the other. 5 seconds each. Borrow pits. Gravel pits. Where you don't have gravel pits, you have quarries. Sand pits. Adits. Yeah, look at the coal. Mine shafts. Open pit mines. Prospect pits. So now you know where 92% of the mining features are in the United States. This is how it breaks out in terms of a pie diagram for the nation, excepting those 3 states and the 2 we haven't started in Puerto Rico and the other places. And when you plot those pie diagrams up, it looks something like that, where the hot colors are things that relate either to coal or hard rock mines, and the cool colors are industrial minerals. It astonishes me how coherent these data are. Thank you.
Well, thanks, Jeff. I think all of you saw from that last slide why Nevada gets 10 of the 15. So I'm just going to point that out to you here.
Thank you for inviting me. And we're going to jump down into the weeds of passive treatment of some of these mine waters. And iron terraces are probably something that you've all seen when you're walking around in the field. All this red stuff flowing out of an adit and down a channel and so forth. And believe it or not, you're looking at Mother Nature at work. It's a process that Mother Nature's been doing for billions of years. And the first time I ran into it was at the Argo Tunnel, which is part of the Clear Creek, Idaho Springs Superfund site. I was walking in 1988 doing an inspection, walking on this crust of iron that had built up over the past, say, 40 years or so, and didn't think too much of it. Do I have a pointer here? Oh, thank you, my savior. And you can see there's a little bit of a terrace formation as we're walking inside the portal. And I thought, oh, this is interesting. What's up with that? And subsequently, I started attending conferences and seeing people presenting data where just a flume was taking out, it wasn't a limestone base, but they were seeing iron removal, acidity removal just in a channel going on. And this particular person, Tiff Hilton, he's a character, West Virginia Mining Conference in Morgantown, presented some really interesting data, and he thought it was bugs. Yeah, bug central. He's seeing these iron terraces and channels and so on. And so I'm taking all this in. And then I had this aha moment. I was looking at the Tiger Tunnel with Jason over here. And I saw these pine needles outside of a port draining at it. I had my geologist pick with me. I'm a mining engineer, but I still have a geologist pick. And I started, I'll just scrape at this stuff and it's going to come out just sludgy. It was hard as a rock. And I turned to Jason and said, how long has this trench been here? He says, oh, about a year or so. And okay, bing, something's going on here. And so I thought, okay, started looking at going back to all these sites that I'd visited, and I'm seeing some common threads. I'm seeing ferrous iron, forest litter, turbulence in the water. I mean, I've got a number of different sites. This is a Rock Creek in Kentucky. Again, the Argo Tunnel. This is an Ornod Superfund site. This is an underdrain under a tailings facility. And again, a lot of these common things. And algae living in pH 2 water. You've seen this. What's going on there? How can these algae survive? And what are they doing? I don't have enough time to get into the weeds here, but also saw this at the Elizabeth Mines Superfund site at the bottom of a TSF. I'm seeing precipitation. And the thing is, in terms of passive treatment, you think of passive treatment, oh, that's wetlands, aerobic wetlands, or maybe it's a biochemical reactor. And where are the plants in this? What's going on? There's no alkalinity in this water. And so also down in the lower right-hand corner, I saw ferrocrete that predated the mine. This was in a USGS publication that was available at the site. So started looking closely and seeing again, these, ferric deposition in the high velocity flow zones. I'm seeing some leaf litter, seeing biofilms, maybe the mineral schwertmanite on the surface of the mine water. You've always seen these biofilms. What are they doing? And so started putting all this together and saying, okay, how does this fit in what I developed as a periodic table of passive treatment? Anything in blue can be reduced, this is kind of an oxidation reduction potential diagram. Anything in blue, you can take it out anoxically with the biochemical reactor. Anything in orange is an aerobic process. And so where do these iron terraces fit in this? And it's kind of a special case of an oxidizing situation, but a lot of other things happen with iron terraces. We have things absorbing to this ferric hydroxide. We can, chromium, moly, copper, nickel, cobalt, and, arsenic is a given. That's pretty common, but selenium also. And this is a site in Arizona where I thought we saw some beryllium being precipitated on these oxyhydroxides. So we tried to take this and tie it into, kind of a test kit concept. And the question I'll just put out to the audience for these process chemists and geochemists, how do we do this? I've got some ideas, but looking to hear from you. So that's all I have. Thank you.
Thanks, Jim. Sorry, this is Ginger who already spoke.
Thank you. Thank you for inviting me. I'm really honored to be part of this group of such diverse specialties that are trying to solve a common problem. You've got my bio. I just want to comment that I work for the New Mexico Bureau of Geology and Mineral Resources. We are the State Geological Survey, the state USGS, if you will. We were created in 1927. We are a research division of the New Mexico Institute of Mining and Technology, one of 12 mining engineering schools in the country. So I do have access to students, and I've had them most of my career. I have been looking at inventory and started out with uranium back when I started with the Bureau as a baby geologist in 1980. And the idea of this program, and it's developed into the AML, but it also has a lot of other uses, including mineral resource assessments. But it is to provide you all with a lot of the information that you need in order to do these reclamations. My work really is involved at the very beginning. I am trying to understand the geological processes that go into creating these AMLs, go into the resources, to developing how these mineral deposits form, but then also the geological processes of what happens to this afterwards. After you all even do your reclamation. Not all of the sites have been remediated properly or have taken care of a lot of the environmental issues. And so ultimately our New Mexico Mines database, which we do hope to get up online, it's to include all the information that not only you all need to do your characterization and to do your selecting of which sites get properly looked at, but it also is valuable and for us to understand where mineral resources can and may be developed in the future. Some of the projects that we have actually worked on, I was heavily involved with the Cuesta project, looking at the effects of weathering on mine waste stability. And that was, there's a lot of reports out on that. And I have some strong opinions on our research. We've looked at geochemistry of legacy mines throughout the state, and now that very geochemistry is going to be used to help us try to identify if there are critical minerals in any of these mine wastes. And we hope to get additional funding through some of the other USGS projects to actually look at this on a couple of sites. A lot of my work's been on uranium, but I've also done a lot of work on hard rock, rare earth, and other critical minerals, and now I'm learning how to do coal. We also worked on the Pecos River project when we were looking at stream sediments and actually seeing that from this volcanic massive sulfide deposit, we were seeing material eroding and actually moving downstream all the way until we started hitting the Paleozoic sediments. And then sometimes dilution's the solution. And from there south in the Pecos River, we really didn't see any more metals. They were diluted. But upstream of the village of Pecos, we definitely did see some hot spots. We've had a very extensive history on looking at uranium and the mobility, not only in making ore deposits, but also in the reclamation afterwards. And the inventory of mines in New Mexico is a very important part of what I've been doing. We hope to continue working on this. That's why I'm still working. I'd like to work with my students. We've got a number of them. Some of you very well may have hired some of our students. And that's where the future is. And these are just some of the conclusions. But ultimately, the bottom line is that every site's different. Every site needs to be specifically characterized. And we do look at microbes occasionally, although I tend not to get too involved unless I have to. We did look at aquatic insects on the Pecos project. And so, you know, these are where some of the cooperative research projects that we've had and some of the agencies that we've actually have worked with over the years. And I plan to be around a little bit longer because I'm pretty much excited about what's finally going on, not just in terms of AMLs, but now we may be able to really link this with production of critical minerals and other minerals from these AMLs. So we'll see where the future goes. But thank you very much for letting me have a say.
Hi, Ginger. Now we have Jason from Trout Unlimited. And like I said before, he's boots on the ground, and hopefully he'll be able to show us some examples and maybe even talk a bit like you've done in the past, Jason, on how you guys went through the process of getting your letters. Okay. Yep. All right. Thanks, Jeff.
presentation.
Just give Ginger's again. I mean, it was a good one. You could just use hers.
There's still a few more slides. You can go through them.
Thanks, Jeff. So those of you that saw Corey Fisher earlier today, I am his other half doing on-the-ground reclamation work. I manage the abandoned mine program in Colorado, background in environmental engineering. So for the essence of time, we can kind of jump in, but thanking MMSA for having TU speak again to share some of our projects that we're working on. So our role on AML projects, for those of you not aware, we are a Good Samaritan, voluntarily cleaning up contamination at orphan mine sites, typically under CERCLA. We're trying to alter the PRP mindset where feasible. What I mean by this is breaking down the impression that all mining companies and all industry have bad intentions. We've had historically good relationships working with Freeport-McMoRan, Newmont Mining for long-term projects in Colorado that we've been completing there. So trying to alter that mindset. One particular project where this has been happening is the Governor Basin project outside of Ouray, Colorado, where TU was initially seeking an administrative settlement order and agreement on consent, but now we're working with the EPA, Forest Service, Ouray Silver Mines, who's a willing PRP. So whereas we were looking to take on the cleanup as a Good Sam, we are now working as a removal action contractor that we put together the work plan. We've procured a contractor, a subcontractor to come do the work to ideally have this up and running by this July. And this is the Governor Basin project. It's a pretty complicated site. It's about 10 acres. It does have an active mining footprint, a very small area where you can see the vent raise and the equipment, but we're not working on that. We are working on the inactive mixed ownership claims, which are a mix of patented Forest Service and claims owned by Ouray Silver Mines. There's 3 waste rock piles, 2 draining adits, a bunch of other fun stuff on this site, but it's a pretty complicated one. And then we're working with the agencies to streamline a more standardized approach for AML projects. And I've mentioned EPA Region 8 before. They've taken really big strides to define 2 Good Sam specific on-scene coordinators to help Trout Unlimited, other watershed groups shepherd their projects through the process and know what you need to kind of do this CERCLA checklist that Ann mentioned earlier today. And then advocating for Good Sam legislation while continuing to complete AML reclamation projects. Tani said this earlier, like trusting and having confidence with the agency, showing that we have a portfolio of projects that we know how to do this work to then build up this legislation that they're working on. Program totals, just specifically for Colorado, last year we did 1.1 or 1.3 million towards sampling analysis, design, and construction across 10 projects. A couple case studies, the Atlas mine outside of Ouray. This is before and then 1 year post in situ phytostabilization, run-on, run-off controls, some stream restoration work, and then sourcing riprap locally at the Mount Emmons mine site outside of Crested Butte to do some clean surface water controls. And then we've kind of continued to build on this existing model supporting local businesses and economies, especially during the pandemic. This has been pretty important. On average, we pump in about 1.18 million to the Colorado economy just from my program, notably to local suppliers, contractors, and businesses that take on these projects. Other notable successes, empowering local, lower income and rural communities where these AML problems exist. Partnerships specifically in Creed, highlighting work with Headwaters Alliance, where TU in-kind funding and expertise is allowed for mentorship and education around these complex AML issues. And this has resulted in tangible designs, procurement documents, funding, and future on-the-ground restoration on Lower Willow Creek, which is shown here. And then for what Ginger was saying, educating the next generation of AML practitioners. I work a lot with Western Colorado University. My colleague Lauren Duncan, who Corey mentioned earlier, works with School of Mines. They actually just had a graduate challenge yesterday that she was helping with. Colorado Mountain College and then CSU, giving guest lectures with these universities. And that was a trip with Western Colorado University last year. So other industry collaborations, one we've been working on recently is Upper Jordan Creek assessment near Silver City, Idaho, partnering with Integra Mining and Delamar Mining. And Carrie Monahan, who's actually on this panel, helped me develop the sampling and analysis plan given the total mercury contamination in this watershed. And we've also been collaborating with Department of Environmental Quality, Fish and Game, EPA, and other stakeholders for this project. Conducted a low flow sampling this past October to bracket suspected low level mercury sources in the upper watershed, being former mill sites, which were some of our main targets, and also monitored soil chemistry, stream and riparian health, and culvert conditions for fish passage and aquatic organism passage throughout the watershed. And then we're working on a subsequent report right now to provide short and long-term recommendations for approaches for reclamation based on eco site screening levels, human health, water quality, et cetera. And this is some of the data that we came up with. Again, with this being a listed segment for mercury and then downstream methylmercury contamination, the upstream sites or sites on the x-axis, total mercury on the y, are control sites, Jordan 1 and 2 showing below chronic standards. And then once we actually hit specific mining features, 3 mill sites in particular, we get a spike an order of magnitude above chronic standards. So again, doing that initial site assessment. And then types of projects we're going to look at are aquatic organism passage, habitat, total mercury reduction, road improvements, and revegetation throughout the watershed. So one of the last things I'll talk about, and this was kind of going around in the discussion today, is what do we consider effective best management practices in the AML industry? TU's working with Department of Public Health, Environment, Division of Reclamation, Mining, and Safety to determine effectiveness of BMP in our industry. Looking at 6 specific Section 319 non-point source projects funded across Colorado. So we have a really good pre and post data set for these sites. Looking at parameters such as water quality, loading, benthics, fish, soil chemistry, vegetation success, some of the things that we're talking about. What is the long-term effectiveness of your in-situ work or your CAP? The function of that, run-on, run-off, longevity, bulkheads and their effectiveness over time. And one of the other aspects we're looking at, given a changing climate, is what does your reclamation do for CO2 offset? Can you capture some of that carbon versus a bare ground site versus what you do in the long term? With the goal to create a standardized effectiveness measure to help us kind of pick what our BMP should be in the future to best work on these projects. So I think in our industry, we're so quick to move to the next project and really taking a step back to look at what defines an effective project. So with that, thank you.
Excuse me, this is Travis Snyder. I don't have my notes in front of me. I'm not sure. VP of Sustainability with Sonoran Copper, and he's going to talk a little bit about the Cactus Mine, formerly known as the Sakatone Mine. It's a brownfield project they're redeveloping. So how about it, Travis?
Great. Well, thank you all very much and allowing us the opportunity to talk about our project. Of course, this is not the right presentation. So first, the little tiny print from our lawyers about cautionary statements. I'm going to have to flip through this because for some reason you guys have a different set of slides than we have. So I just want to tell you guys that, this is kind of our mine site area. This is the old Sakatone mine. This was a site that was mined from 1974 to 1984. It went through bankruptcy with ASARCO and was put into an environmental trust. We did acquire it from the environmental trust. We were looking at an area, we were trying to identify an area that would fit a good SAM opportunity. And we think that this is an ideal site for cleanup and also to bring the project up to modern day environmental standards. Some of the criteria that we were looking for was, in a good jurisdiction, meeting the current framework that we have, current legislative framework that we have. So we did acquire this and have spent about $40 million in developing it and bringing it back into production. The first thing that we're going to do is actually take and work on the stockpile project area. This is an unlined facility with waste rock material that also has sulfides and oxides in close proximity, and it's unlined. During the time whenever ASARCO was mining this, it was under a groundwater protection permit, so not the more robust aquifer protection permitting program that we have today. We have drilled and we the resources that we have on site are about 1.6 billion in indicated and 1.9 billion pounds of copper in inferred. So my apologies. I think I sent you guys the wrong presentation. Yes. We had a different one set up. My apologies. Let me go back to, this was a much more robust, so now I know why you were worried about time. So let me just go back to the overview. So our plan is to take and mine on the stockpile and then also reopen the pit. And there's two potential underground deposits, Cactus East and the Park Cellular area. You know, we're very excited about this project and we think it does demonstrate Good Samaritan.
Travis, why don't you talk a little bit about where it came from, where the whole concept came from?
So this actually came from Adam, who actually had a conversation with state. Actually had a conversation with EPA about finding a project. This actually came from DEQ. This was one of theirs in their inventory that they knew because the beneficiary of that trust was the taxpayers of Arizona. And there was money set aside for closure. There was about $20 million, but it was not going to be enough to do a full closure on this site. And DEQ and the state didn't want to have this liability moving forward for the rest of eternity.
Just to build off of that, for the site, you're looking at both a reclamation, restoration, or improvement piece, but you're also looking at a reopening of the mine.
Correct.
As well.
Correct.
Okay, so it's a dual purpose.
So the stockpile at the bottom there, that's where this project started with, because back in the day, they didn't know how to process the oxides. They knew what to do with the sulfides. The oxides, they just put in a pile, and they did it according to environmental standards at the time, which was an online facility, which today is not in compliance. So in the effect of just processing the oxides on this site, you're improving the baseline environmental conditions of the area. And as it turns out, Travis, we've done a little bit more drilling here, and there's a fair bit more copper. What do you think?
There's a lot more copper still left.
Yeah, and although I guess it's not quite technically an AML site, it's a great example of a brownfield redevelopment site. It's very cool. And our last speaker is Carrie. Well, actually, before we do that, I want to introduce Adam. He actually is sitting up here on the panel because he's probably going to have a lot of input and value to the panel discussion. So we've asked him to sit up here. He's been working with Travis on this project. And for those of you who don't know Adam, he is the president of Global External Relations, which is an organization that works on helping their clients, primarily mining clients, to define social, political, regulatory, and reputational risk issues around developing projects. And he's got a background actually in Washington, D.C. He was a staffer in the Senate at the beginning of his career. And he's worked for several other large external relations firms over the years before founding Global External Relations, and a former president of the AEMA organization in the US. So thanks, Adam, for being here. We look forward to your input. No, I don't want to stop you. Okay, it looks like Carrie's got hers up. Just a few things, and Carrie, I'll let you introduce yourself as you get started. as well. She, as I said before, she's the Sierra Fund Program Director. She also works with California State University at Chico as a lecturer there. So, Carrie, can you hear us?
Yes.
You ready to go? Ready to go?
Yeah. Can you guys hear me? How is my microphone?
It's a little loud, but I think it'll be okay.
Yeah, I might get excited and start talking this loud. Am I going to blow your ears off?
Sit further back and you'll be fine.
I got to press forward, but okay, I got it. Well, hello, everyone. Thanks so much for having me in this strange hybrid world that we're living in. I would have really liked to have been there with you all, except we have our 20th anniversary today for the Sierra Fund in Sacramento. And so I have to be there this evening, and it was really hard to be in both places in the same day. So thanks again for tolerating this online version of being together. So today I'm going to talk to you about some of the mine remediation projects we have going on here in California. The Sierra Fund is located in Nevada City, the heart of the California gold rush. And our mission is to restore ecosystem and community resiliency to the Sierra Nevada from the impacts of that gold rush era to both the communities and those ecosystems. So here on the title page, I have a iconic picture of hydraulic mining, and it was in fact invented here at Malakoff Diggins, which is now a state park. And that's a picture of it on the left today. I think of it as a kind of a beautiful disaster and a reminder of all of the work that took place during that era, and also how much we are still living with the ongoing impacts from that time. I love all the inventory presentations that went on earlier. California has over 40,000 abandoned mines on that PAMP or TOMS database, those topographically occurring mine symbols. And each of those has some sort of chemical and or physical hazard. That's such a huge number. How do we narrow this down into something that we can do? How do we prioritize into getting more work done? Excuse me, I'm trying to advance. There we go. So unlike some of the conversations earlier where we were talking about, let's pick the kind of the worst problems first, we started thinking about what are the mine sites, the abandoned mines that are in areas where work is already going on. And so what you have here to orient you is Lake Tahoe, the footprint of Lake Tahoe here. And this is where hydraulic mining was extensively done in the Yuba and Bear River watersheds just north of Lake Tahoe. And so we started working with our partners at Tahoe National Forest to create an inventory of the hydraulic mine sites. This is something we could do with the 2014 LiDAR. So we were able to delineate each of these hydraulic mine sites using the LiDAR and this topographical signature, if you will. We can then even use the LiDAR to get volume estimates of how much material was exhumed. And we can see other features from the LiDAR. This is a debris control dam down below these hydraulic mine sites that was built later on so that hydraulic mining could resume after the Sawyer decision halted it because so much material was going downstream. So we just went from 40,000 abandoned mines in the state to a mere 400 or 500 certain specific type of abandoned mines, these hydraulic mines. And these hydraulic mines are in the middle of these forests where a whole lot of fuels reduction work is taking place. So in the bottom corner of the slide, this is the Trapper Forest Health Project. It's a 31,000 acre site. And all of those red polygons are the fuels reduction areas where work is planned. And all of those yellow polygons are hydraulic mine sites. So when they started this work, they were actually going to avoid these hydraulic mine sites and not include them as part of their fuels reduction work. And I think because of the inventory work we've been able to do, we found ways now to include that as part of watershed restoration, fuels reduction, and forest health. This is a picture actually at Malakoff Diggins. These hydraulic mine sites matter. We need to clean them up. They have ongoing water quality problems with both turbidity and particulate bound mercury. In addition to the water quality problems, we have massive erosional events at these sites. And it's actually the amount of material coming off of these sites that we've been able to estimate using terrestrial LiDAR with our partners at USGS. And that material is going downstream and getting in the way of operating water supply, water diversion facilities. And it's costing millions of dollars a year to maintain those facilities because so much of that material is coming down from the hydraulic mine sites. So that is why people want to see some of these sites cleaned up. It's not just to do good, and it's because they're big parts of the forest that are going to burn up if we don't do anything. We have to get in there. And it's because the amount of sediment coming down off these mine sites is making maintaining these facilities very difficult. So coupling this multi-benefit approach has really allowed us to move forward. Key to our work is working with both federally recognized tribes and what we call traditional tribes. There are many traditional tribes in this part of California that don't have that federal recognition status and have created like a nonprofit in order to represent themselves and do work on the landscape. Those tribes are interested in getting the fuels reduction work. They're interested in doing the erosion control projects in the forests, on the mine sites, and we've worked with them with meadow restoration as well. So in the bottom left here, I have what we call a beaver dam analog, and it's part of restoring meadow hydrology in these landscapes, and it's part of process-based restoration. And that traditional ecological knowledge and process-based approach to recovering legacy landscapes is informing what we plan to do at these hydraulic mine sites. Because you could look at these as messed up sites that warrant going in and starting over, or you could look at these sites as this is what they look like 170 years of natural recovery. What can we do here to promote more recovery in a quicker time frame, but not destroy what's already working? So we're looking at the big question of what is hydraulic mine remediation? What does it include, right? These are non-CERCLA sites. The amount of mercury coming off these sites is incredibly low research levels. And that has made Forest Service much more comfortable with us talking about going in there and doing a series of pilot projects to improve soil health, to improve water quality, to promote revegetation, and of course, to reduce the fire risk. And if we have ways of using this product called biochar, which I'm going to talk about in just a second, we're also looking at a benefit with below ground carbon sequestration. So biochar, very simply put, is charcoal. It's made from this woody biomass, this non-merchantable timber that is being cleared as part of the fuels reduction work. It's burned in a controlled environment where the emissions are captured, and that burning process is stopped before that material becomes ash. So this is charcoal. I like to explain to people, the lay audiences, this is like your Brita filter. It's really a no regret solution. And there's a lot of it being made because of how much fuels reduction work is happening and how fast that's happening. So we looked at the effect that biochar could have, the benefit it could have on water quality. We collected hydraulic mine debris and we passed clean water through that hydraulic mine debris with 0, 2, and 5% biochar mixed in. And then we measured the turbidity, total mercury, and filtered mercury that came out as an effluent, if you will. And what we found is that with 5% biochar, and this is a publication we have here, we see a significant reduction in the amount of dissolved mercury in that discharge. So we know already from a series of research that's ongoing that biochar is a good choice for promoting soil health, for promoting infiltration and revegetation. It also has these added benefits to water quality. The biochar industry is one of these really exciting new technologies. There's a lot of people who are thrilled about the idea of biochar and all the good that it can do in the world. And they were super happy to find out that we had all of these abandoned mine lands that might need that biochar. In other words, they're creating so much of it, they don't know where it all should go. So we designed a pilot project at Grizzly Creek Hydraulic Mine, where we're going to put a series of test plots in this barren area of the site. And the test plots are going to have biochar all by itself, like lasagna on top, biochar and wood chips layered on top of each other, biochar mixed in, and then of course control. And we'll look at soil health properties, revegetation over time, and we'll also look at water quality runoff. For the Grizzly Creek site, we also have a reclamation plan that we are looking for funding for. And I want to bring up this, again, the big question of what is hydraulic mine remediation? Because for this site, it includes 50 acres of fuels reduction. It involves a bit of land recontouring to reduce erosion, stabilizing 2 different head cuts, stabilizing a small debris control dam, and then using biochar and wood chips as soil amendments. So we're looking for a series of other ready to proceed sites where we can apply biochar at scale, following what we've learned from these test plots. Thanks.
Thanks. Thank you, Carrie. Oh, there we can see. Well, I can see you. Oh, everybody can see you. Say hi. Wave, Carrie. Nice to see you. Sorry you couldn't make it. Okay, time to move on. Time for discussion. First of all, Anne's going to run around and get some of her steps in for today with a microphone. Are there any questions from the audience? I mean, obviously this is a very broad range of topics that we had discussed. So we could have pretty broad range of discussion if people want to carry on even with some of the stuff we talked on before, particularly as it may relate to some of what you've just heard, or you feel that, well, I have a bunch of questions myself and I'm already ready to fire at these folks. Questions from the floor, somebody. There we go. And remember, if you haven't already spoken, tell us who you are and who you're representing.
All right. My name is Jeremy Colliard. I'm with SLR. I'm with consultancy. So I have a question on cactus because it seems like this is a really interesting approach to an AML. With the property ownership, mineral rights, that sort of stuff being part of this, essentially down to ADEQ. And has that been transferred to you guys? Are you now private property owners? Do you own those mineral rights? How did that all work out?
Yes, so it is all private surface, private minerals. So we did purchase that from the trust. There's been some consolidation of some adjacent lands to it. This whole project started with the concept of how do we do a Good SAM project without Good SAM legislation. And when we started to back out all of the inhibitors, which are decades of NEPA and litigation, all of the different compliance hits, and then the ability to be able to do the legacy liability carve out. What we really arrived at is that your concept is going to come from one of these custodial trust projects, and I can't say enough good things about the folks at DEQ for really kind of helping to identify some of these. And we've had other projects that have come out of these mechanisms before, and I know that this isn't a traditional AML, but this site is proof that when you get policy out of the way, when you get the legacy liability portion out of the way, you can take something that's a taxpayer liability and a blight on the environment and turn it into a win for everyone involved. And just to put this in perspective, this was something that the state was potentially on the hook for somewhere, we'll just say in excess of $10 million. We just did an economic impact study on the effects of reopening this mine, and it come back with the fact that it'd be $8.6 billion when you combine direct, indirect, and an induced economic activity associated with that site. That's the equivalent of bringing a Super Bowl to Casa Grande every other year for 2 decades. Hank knows this. You don't get foreign direct investment that often, and you certainly don't off of things that were liabilities previously. And that's a very long-winded answer, but thank you.
I actually have a follow-on since we're talking about cactus. I'm curious, Travis, when you guys were doing your economic analysis of this and building your feasibility study, how did you account for that? I mean, the cost of doing the reclamation work you're going to do, the additional, because it's not traditionally, here's how we're going to open it, here's how we're going to close it kind of thing. It's a bit different. How did you guys factor that in?
Well, actually in the waste rock dump, there's actually a lot of oxide ore that's still in there. So it's very economical for us just to move it over and start a leaching process on it.
So you basically just consider that your ore source essentially?
Exactly, to start off.
And then whatever new facilities will just be part of your obligations for closure? And what about the other facilities that have already been closed that you won't touch?
So the tailings facility has been completely reclaimed. So we do not, that will stay in place.
Okay. And so you wouldn't have liability associated with that one?
So that
other than obviously circle of liability, we all know about that, right?
That was part of the carve out that we did both through the EPA and through our Department of Environmental Quality here. The EPA vehicle was what's called a BFPPA, or a bona fide prospective purchasers agreement, and the state equivalent is called a PPA, or a prospective purchasers agreement. They used a similar mechanism for Hermosa, which South 32 is working on in the southern part of the state.
Okay. All right, thanks.
A question to kind of follow on, Travis, are there minerals remaining in the tailings that might entice you, especially on the critical and strategic aspect, that might entice you guys to open that back up and reprocess and therefore reclaim it again?
That's actually a really good question. We have actually, through some of the drilling that had been done in the past and through the heads and tails records that we had from the site, we did notice that there was about 20 million pounds of copper still contained in the tailings, with 80% of that already being in oxide form. So it potentially could be vat leached at some point.
Thank you.
Any other questions? Okay, I have a question, to everybody in the panel, but specifically to Jason and Carrie as well, since I know this is some of the work that you've been doing. We talked earlier, and we've talked in previous summits about the need for having an agreed upon approach for characterizing sites as part of the planning process when we're ready to get into it. And so, and maybe even Jeff, where have we gotten? It seems from Jason, from what you said, and you showed us, that you guys have started to develop some kind of thinking on this area. Do you guys have a internal guidance or thoughts on this? And Carrie, I know you've done a lot of characterization work as well, and probably Jeff, I would imagine too. So throw it open.
I mean, I think one of the things when we're doing watershed-wide assessments for a little bit bigger projects, we try to model a lot of what we're doing after what EPA does on their like site assessment for like a Superfund site, to make sure that we're generating the same type of data. So like the ecological site screening levels, like that's a specific thing that you'll see in like a remedial investigation. And some of these other things, like when we're going into depth for like that big of an area, we'll take on that. But I think like Ginger was saying, every site is different from an AML perspective. So, sometimes that site assessment changes and is different on what your removal action goals might be for the project. But I mean, I think modeling after the agencies makes it a lot easier to pitch a project to an agency to get them to approve it. So I think that's why we've been doing a lot of our site assessment work along those lines.
Are there things you would change in that if it wasn't for the need to try and sell it to the same agencies? I mean, are there things from the Superfund type characterization that really wouldn't apply or shouldn't necessarily apply to an AML site?
And maybe rephrase, we don't do all of it. I might pick and choose.
Okay, you pick and choose.
So, I mean, we don't have that budget, like we talked about in the earlier panel, to really get that far into the weeds. So picking and choosing what's the most appropriate for, what your end goals are for the watershed and the project and all your partners, and having those in like the preliminary assessment is kind of how we've been doing things.
Okay.
So
there's a couple things here I could chime in about, if you guys hear me. One is understanding that how the site was operated previously to inform your assessment. I know that sounds so obvious, but it's part of the cultural resource assessment. So if you can get your cultural person and your geologist in the field at the same time and have that judgmental sampling be part of the looking for hotspots, then you have a much more informed assessment. That's something that we like to talk about a lot. And it has worked well for us, especially when we're assessing a property before it changes hands. And we want to do the due diligence as part of that real estate arrangement, so that the new owner, which in some cases is tribal nonprofits, knows what they're taking on and what it will cost to clean it up. So finding as much as the problem as possible can be based off of the site's operation can be really helpful.
Thanks, Carrie.
Can I add to that a question that I had written down? In your Colorado, this is for Jason, for you.
Get the microphone closer to your face.
In your assessment process, is that a template that could be sort of transferred to other states, or was this kind of a hard fought process that was specific to Colorado, and that there would be a very similar process at other states because there's unique conditions, i.e. is there something that can be carbon copied and taken to other states to initiate the characterization process?
I think in general, if you take away the site-specific aspects of it and you put in a boilerplate approach, you probably could do that. I mean, I know USGS has their standard sampling suite too of things that they're going into the field to look at, and we've worked with them on multiple sites and shared data with USGS in the past. And I mean, I think that there would be, it would just be getting all of the partners in the room, like I had mentioned earlier, our mixed ownership group, to kind of define what those site assessment characteristics would be. But we, like I said, if we're following what EPA is doing on a lot of their projects, that's a good place to start.
And Carrie, for you, the LiDAR stuff, the LiDAR data set that you used, is that public domain data? So we could all benefit from that? I'm getting a nod from Jeff at the table too.
Yes, absolutely. Yeah, Jeff would know there's a lot of aerial LiDAR available for the majority of the country at this time. And I think one of the newer fields, I guess, is how we use it. We can identify a lot of features if you know what you're looking at, and then you do some ground truthing, the ditching that took place, the debris control dams at its shafts. It can be seen with that LiDAR, and that can really help inform your assessment efforts. So yes, publicly available.
That's great. Looks like Virginia's got a comment.
Well, I just want to go back to the characterization part of it. One of the, under the USGS Earth MRI project, they now have been tasked with looking at mine waste, and we're trying to see if we could work with USGS there in New Mexico to actually develop sampling protocols on how we sample these mine wastes in order to get an estimate of the critical minerals that potentially could be in these different types of mine waste. And so that, I think, is some of the initial work that USGS is kind of going to look at with some of the states' help that have been doing this in the past. And the idea really does come down to it is that we are looking at, in the past, we were looking at the fines because that's what caused environmental issues. Well, now we're going to have to actually shift and not only look at the fines, but we need to look at the big rocks that are also in there and try to figure out just how we can come up with quantifying potential critical minerals that perhaps then we could attractively go after and economically go after and actually remine and process. And that hopefully will provide funding to clean up some of these sites. So it's more than just characterization now. We're actually looking at different types of sampling protocols that we maybe need to capture everything that's in these wastes.
Go ahead, Jim.
Okay. How many of you folks have ever heard of the Mind Map repository? How many hands? 3, 4? Okay, back in the day when mining companies did all their mapping on Mylar or paper, eventually when they closed, some of these maps actually made it to the Federal Center in Denver. And I remember going through paper maps, at least at that time, but just about in, say, the late 1980s, all these maps were taken to Washington, D.C. or someplace and created into microfiche. Remember those? You sit there and you're looking at newspapers and you're looking at a mind map that's like this small, but still they didn't, I don't know if they digitized it, they took photos of these mind maps. And my question is, does the USGS plan to somehow pull all this data? I mean, we're talking about, GIS and blah, 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 but none of it looks underground, really. You need the mind maps and to be able to coordinate that with the site geology. And that's one data source. There's another data source. How many of you folks have ever heard of the Anaconda Collection? This is a great one because the Anaconda Collection was acquired, I think, by the University of Wyoming. And they've got, from what I understand, all these geological reports on all of these prospects that they ever looked at. And they probably have other stuff that, this is part of the knowledge base that I think that you guys are poised to capitalize on. And the other resource, I've got a whole bunch of them on my bookshelves in my office, paper copies of USGS professional papers and US Bureau of Mines professional papers and bulletins that have all these underground mine maps. They're beautiful. They were, full color, and you can see these online. I mean, basically when these bulletins have been digitized, but I've actually used information, a cross section and a plan view of a vein deposit. This is the Ferris Hagerty mine up in Wyoming. We built a 3D model using USGS data. We had the dip and the strike of the vein, and we've got an underground mine map and where the shafts were. And we put together a 3D model to figure out where where the ARD was coming in and where fresh water was coming in. So I think that there's a wealth of information out there that we all need to know about and capitalize on in order to figure out all these abandoned mine land characterizations.
Well, and don't forget all the SCG, the economic geology publications.
Oh yeah.
I mean, I've got bookshelves full of economic geology.
Right.
Well, under this bill that, and maybe Jeff will want to speak a little bit more to it, but under this bill with the USGS MRI, they also have another program that they've called Database Preservation Program. And when critical minerals became an issue and USGS was looking for funding, some of the money went specifically to the state geological surveys for critical minerals. And each state can apply for it. Well, under this new bill that's been passed, a funding bill, that money has actually been up. So not only can the state geological surveys actually apply for money to do other kinds of database preservation and data preservation and scanning of a lot of these maps and all, but we can also use, I've been using some of this to have students logging and photographing core. I've had students going through and adding to our mines database all of these occurrences that Jeff, either the ones Jeff uses or they're below Jeff's threshold. At least we've got them in New Mexico. So you really do need to work in partnership with your geological surveys in each of the states, because they do have a wealth of information. And now there is funding to actually start getting this into formats that we can use, in addition to the sources that Jim's already identified.
You want to comment, Jeff? Absolutely. We'd love to hear what you have to say.
In terms of the Infrastructure Act that was passed at the end of last year, there was allocation for USGS Earth MRI project to take on, to look for critical minerals in mine waste. One of the first steps on that is, where the heck is it? And Jason, thanks for your help for that. Our group, US Men, was asked to help out with that. And you all can remember the first number from today, right? 666, sigh of the devil, right? Here's your next number, 13. 13,000 mine waste features in the United States, except for the 3 states we haven't done yet. Now that conflates coal and hard rock mines, right? And we all know that database is no good, right? But it is the best unified database that we have. So we have been asked to take it from what it is. And we've worked with folks in the state of Colorado, federal, state agencies, NGOs, including Child Unlimited. And we said, what would this database look like? We haven't come to you yet, Ginger, because we wanted to go to our neighbors first. You're next on the line.
I know I'm in there. I have no problem.
She knows what's coming. And we sat down with them and said, we need to build a database that can work on a national scale for mine waste only. What will it look like? And we can't make it so big that it will fail under its own weight. And so we can't have too many fields because then it just will never get it done. So we wanted something as simple as possible, but that didn't leave anything out, that in 5 years' time or 15, we didn't say, oh dear, right? And US Min has had a lot of experience with oh dear, right? So our mineral deposit databases now look very different than they did when we started them. And we've learned from that. And one of the things we've learned is everyone in this room is our friend when it comes to consultation and ideas, because everyone in the room sees the world differently than I do. And everyone in the room has a different vision of what this should look like. And we value your opinions. And so we started out with our stakeholders in Colorado. We've got their input. We'll now be going to some of the state surveys and other people, and we'll be looking for more input. Then we'll be actually sending the database out and asking people to populate 5 or 10 records, because that's when you learn, is when you actually do something. And then it's like, oh, guess what? It's only got 3 tires. It doesn't float. It keeps falling over on the back end, right? We need a 4th tire on this thing. Whatever those mistakes are, we're going to start small, but we are going to reach out and get some collaboration. So that's the mine waste side. And, you know, I mean, there's visions and dreams of doing something that's bigger, that's more inclusive, that's not just mine waste fields, which is about 10. What do we do with the other 52?
Tim Van Weingarten, ACZ Laboratories out of Colorado. Jeff, the question's for you. Some of your graphs, if you look at that from like a politician looking at it, looks like the majority of the United States has mining impact when there's 0.01% to 1% on the, there's some statistics. So it's, ag is about 52% of US land. So
are you talking about surface area?
Yeah, surface area of the state. So it looks like, if you look at that to the uneducated, it looks like, oh man, mining's just everywhere, but if it was actually the scale, you wouldn't be able to see it on the size of your graphs that you have there. So it's kind of a, you can always skew graphs or slides. So what's your comment on that? When you're presenting that to someone that's going to be funding something that,
the first time we put that slide together, Murray Hitzman was working at the USGS. And we showed that slide to Murray Hitzman and Larry Maynard. Larry was the head of Mineral Resources Program at the time. And Murray looked at that and he said, mining is everywhere. And he was really happy because from his point of view, that was a great thing for Congress to say and to notice and to see. Because the slide I normally start with is Earth resources hold the keys to solving humankind's greatest problems. We can't build the next economy. We can't build the next world that we need to build without extracting Earth resources. The greatest recyclable component that I'm aware of, commodity, is lead. Because when your car battery dies, you take it in, they take it out, and they recycle that, and the lead gets recycled. Lead's about 80% recyclable. The other 20%'s got to come out of the ground, and for everything else, everything that's in my smartphone or that's in a battery, those percentages are far lower. So we've got to get all that stuff. We want to build highways, right? Infrastructure Act. We want to build highways and fix our bridges. That's got to come from that other side, all those industrial minerals, right? So, boy, Congress should be happy that we've got mines everywhere, because otherwise, for all those industrial minerals, your transport costs are going to kill you, right? Your transport costs double the cost of your aggregate. I think in New Zealand, our figure was every 10K of transport. Your price doubles. Yeah, you know all that. I'm sorry. I hope I'm preaching to the converted. I'm not signing off. Yeah, yeah. Well, I get it. I get the problems, right? But we've recently completed a round of interviews with people we're trying to hire from the National Association of Geologic Teachers. And these are people who just completed their bachelor's degree. Smart kids, best in their class. One of them was like, oh, I don't know about working on all this mining stuff. And I said, I went through the recyclable stuff. It's like, okay, how are you going to have a green economy if recycling is the only way to get it? Because every year you're going to be dwindling your supply by 40 to 60%, right? We need those new minerals, yeah, to build the world that people want to see, whatever that vision is.
Well, with that in mind, how does reprocessing play? Because that, and how do we do a better job with it? I think I was surprised that in the last, say, 5 years that coal mining is playing into it, because the wastes on coal mines are so rich in rare earths, which we are almost 100% reliant on unfriendly countries. So it's interesting that a new focus on waste at mine sites is affording opportunities, like Travis has shown, of being able to go in and process, remine, and actually extract more of the resources out, because our past processing is not as effective as our current processing. And possibly later down the road, we'll find new ways to go back and extract the waste that we might leave behind.
And yeah, and that process of remining has been around for centuries. The miners have gone and metallurgists have gone in and said, oh yeah, they look at that was waste, but we can squeeze something else out of it. And so, yeah, I think that's going to be something that will continue for quite a while.
Yeah, and we got a great example of that here in Arizona out at Pinto Valley. Jetty Technologies just deployed a new system for better recovery. We're getting to a point where technology, especially when we get into resource scarcity, and when you look at the global supply and what we have in the potential supply chain of copper in particular, as we go forward, we have a huge gap globally. Forget where you're sourcing it from, jurisdictions that don't have our environmental and labor controls. But more and more, it's pushing technology into coming up with solutions. And we've got some really, really cool things on the horizon. We have a number of things that are coming out of ASU Polytechnic in the material science department. I've seen some of the things that they're working on in terms of base metal recovery. It's really, really cool.
So, so when I was working for Sarco in industry, I mean, we were looking at mining the rice dumps at Ray, and because the resource in the ground, you know, our cutoff was 0.25, but we probably didn't have more than 0.4 in the pits where we had the resource model. But when you go and you did sonic drilling or you did RC drilling up on the dumps, when the cutoffs were, you know, about 1% was non-economical. I mean, there's like 1% in the dumps and you're like, oh my God, like 1%. Like, let's just go tear down the dumps. But, you know, so, but then there's engineering challenges behind that. But the industry is already thinking about this, because this would have been a drilling campaign back in 2011 and 2012 that ASARCO had at the time. And if ASARCO was thinking about it, trust me, Freeport was definitely thinking about it. And then just to dovetail onto that, one of the things I've seen in the mining industry recently was a conference that, you know, they do down at Star Pass every year, the Arizona section meeting for SME, where industry is starting to think about not just being, hey, we're going to permit a copper mine. So there's now this new thinking of, well, instead of being one end market mine, because they know that permitting is taking longer than it ever used to, and they know that they're going to have challenges to permitting. So now there's a twist in thinking of, can we be multiple end markets? Like, how can we be more than just maybe a copper mine with just a moly circuit? How can we be a copper mine with moly and maybe with lead and zinc and all of these other things? Because it's just the standpoint's changing. And then there's other markets in industrial minerals where they're looking as well in being more than just an industrial minerals mine. So I think that's where there's just this new twist in thinking because of the things that are just changing in industry.
I like where you're going with it. And I'll tell you, if you want to look at like what the road ahead could have for us as the mining industry, I'd like to look at our food industry. And there was a point where your average food consumer didn't know much about the source and the stewardship of the food that we were consuming. And then all of a sudden, now we've got folks who will pay an extra $2 for a tomato because it's got an extra sticker on it. So I think that might be a fair chug from where we're sitting today, but people are starting to ask more and more about where things come from. And I think they should. And I think we should start to think about like, you know, can we go back? Can we like start to be more efficient about the way that we approach these sites, and especially waste facilities is like ground zero for that, in my humble.
I'd like to ask the tribal community to kind of weigh in on this, because we're talking about reprocessing in areas that have already been mined, and maybe we haven't engaged on the first mining process. How do we engage on a reprocessing process? So Melvin or Bobby and your crew. Oh. Do you want me to ask that again? Do you want me to ask it again, or did you guys hear it before?
Hold up, Abby. We want the people online to be able to hear.
You know, again, I think we look back on some of these mine sites, right? There was.
Could you get your microphone a little closer? Yeah, there you go.
There was no, when you look at some of these legacy mining sites, there probably was no engagement, right, with tribes. There was no, you know, attempt at trying to get some type of consent. So if you're going to go back and reprocess it, I think that's a good opportunity again, even if the original development of the mine did not involve any sort of, you know, tribal input or any sort of stakeholder input. You know, it's a perfect example to say, okay, we can go in, maybe we can clean this up a little bit and also get something good out of it, you know, for our new green economy. So again, it's just, you know, engaging, and even if there was not initial engagement, it's just making that step, you know, to work with tribes. And sometimes you can, you know, kill two birds with one stone, so to speak, you know, clean up the mine site and also get some good minerals out of it.
So this is Carrie Monahan online. Can I jump in for a second, or was there another tribal member who wanted to speak on this thread?
Everybody who's using the microphone, could you please hold it closer to your mouth? It's
okay.
It's even hard to hear up here, let alone the people online. Thank you.
I'm a person. Good morning. My name is Jacob Henry. I'm with the White Mountain Apache tribe and also a member of the Western Resources tribe. My question was based on how many tribes have you worked with in the Southwest, mainly in the state of Arizona? And then relating to what she is saying, East Central Arizona is considered the copper corridor. But if you go an hour's drive towards Salt River Canyon, the headwaters that starts the Salt River, you have abandoned asbestos uranium mines. Nothing has ever been done. It's a recreational area. And based on what she brought up, there is a lot of things related to traditional, I guess, vegetation medicine there besides the fishery? And how would the tribes go about asking for assistance to clean these pits up, these open pits, adits that are along the riverbed? And then you got Canyon Creek, which was once considered the cleanest water in the state of Arizona at one time. It also has abandoned mine pits that nobody has bothered. They were just, you know, a lot of the mining up there was stopped in the mid 70s, but since then, nobody has gone back to clean it, do anything about it to make sure it's safe. And the Salt River, as you know, empties into the Roosevelt Dam and then empties into the Phoenix metropolitan area. So we don't know how much of it has been contaminated in the past and how much of it's still doing that with the erosion process that was brought up earlier. So, you know, I was happy you guys brought that up. We related to the erosion, related to a lot of the terraces that happens from that, a lot of the waste that is there, because we do have a lot of that up there that was left behind them from a lot of the companies that left.
Natalie, it looks like there may be a partnership here, and one of those top 10 from Arizona could be right here. So, yep. Are there other questions from the crowd? Got one over here. Getting my steps in.
While she's walking over there, Adam, where does food come from? Come on, we all know it comes from the grocery store, right?
Yeah, and power, your electricity comes from their socket over there.
Yeah, exactly.
So.
Exactly.
Hello, everybody. I'm Paul Marsh. I'm the state mine inspector, and I just wanted to put a little different twist on what Adam was saying. I'm probably the only politician in the room. So as I go around and talk to citizens of Arizona, I routinely get, we have mines in Arizona. I mean, that is the common theme when I talk to citizens of Arizona. So to that point, we need to do a better job of educating people. You know, we have abandoned mine lands. We need to educate people about what we did in the past, what we're doing now in the present, and what our plans are for the future. Because if we're not educating, it's the same as what Adam said. You know, look, where does our food come from? It comes from the grocery store. Where does our power come from? It comes from the light switch. You know, and I hear that with, well, I'll just go buy an electric vehicle. They have no idea where those materials come from. So we have to do a better job as a group, as a whole, to educate the community.
Great point. Carrie, did you have a comment you wanted to make?
Yeah, thank you. I just wanted to chime in. I can't tell who's speaking sometimes, but people also are not aware that there was ever mining here in California. I would say the majority of the environmental movement has said, what? There's mines here? So as the heart of the California gold rush, which was obviously seminal to our nation, and when you bring up tribal consultation, I mean, it was mass genocide here. People were forcibly removed from the landscape as a result of that gold rush era. And when those original stewards were removed, we then have the forest conditions we have today in part as a result. So those thousands and thousands of native peoples that were here, they were managing this landscape. They were using prescribed cultural burns, if you will, to avoid these catastrophic wildfires. And that's what's changed perspectives here in California. When every year for the last 4 years, I've been evacuated from my home, all of a sudden something in the middle of nowhere, forests, seem really, really relevant to people, whether you're living in urban areas of California or rural. Our air quality is hugely affected by this. Why are our forests in this condition? We stopped doing prescribed fire. Why did we stop doing prescribed fire? Because we removed the people who knew how to steward this land. Why did we remove those people? Because we were in it for the goal. And we're still here. So it's about bringing back that original stewardship component to every single one of our projects. Having tribal consultation not just be a formality, but be part of the prioritization of the sites, be part of designing the reuse, not just on revegetation plans. But I think There's two aha moments for me on working with tribes that I just want to try to share with you all this different perspective. One is that natural resources are cultural resources to the tribes. Like having the ability to practice those cultural burns is part of their culture. And what does that mean to not be able to practice your culture? Imagine at Thanksgiving time, you were told you cannot have turkey be at your table. It's like, what are you talking about? We would feel so wronged if we couldn't practice some of those cultures. So bringing tribes in at every aspect of this is key to having ongoing future stewardship of these sites. Thanks.
Thanks, Carrie.
Hello, everybody. My name is Leroy Sinlaitua. I run the Tribal Monitor program here with Westland Resources. And when dealing with tribes, I think we need to assume that no tribes were ever consulted on any of these mines. Any kind of legacy, anything that happened, laws were not written to have the tribes involved. So we need to start from ground zero when we're talking about any kind of engagement, not just consultation. We're talking about consultation as we use that word, but we also need to look at engagement. We're looking at a site like we're talking about with the copper mine that's going to be coming there in Casa Grande. It's considered private land, so there's going to be no consultation with that. But we need to look at engagement. That's where we need to be talking about more when we're talking about these lands, because any legacy site, like I said, as was told, people were moved from these lands, so there was no consultation when it was happening. So we are working, you'll hear more about our program and what we're doing and trying to get this started, getting this conversation started. So I think as we talk about working with tribes, we need to start that conversation with them also. So it's not something that is by law we need to do, but by knowing what's right and knowing what we have done in the past, we need to start this this conversation. And I think that's what's important here as we need to get across.
Yeah, that's a really good point. I mean, I think we've seen the importance of having a broad spectrum, a real broad spectrum of people involved in this discussion, because it really only took off and we only got where we've gotten with the Good SAM bill when we finally were able to broaden the coalition that was working on that. And the more people we can get involved in this whole discussion on AML and how do we deal with it in Good SAM, the better off we'll be and the more likely we are to actually accomplish something. Tani, go ahead. Before we break for lunch, I do want to take a few minutes to raise one more issue. It's one of the elephants we've had in the room for years, and I want to make sure we put it on the table. So, no, go ahead. Weigh in, Tani, please.
No, just listening to the conversation today, we started this morning with Good Samaritan legislation, which, just to be clear, was designed for organizations and companies to go in and make environmentally beneficial impacts on the community. It didn't have to do with going in and making a profit or starting a new mine, or I hear the term remining. When you take that back to DC and with some of the opponents of Good SAM, they look at Good SAM as being, no, companies just want to go back and remine outside of the normal permitting process. So I just wanted to draw a clear line between the Good Samaritan legislation we talked about this morning, and then also these really great projects that are starting to pop up in the Western United States that deal with BFPPs that see not only a business opportunity, but within that, because companies are so focused on environmental social governance and giving back to their communities, they see an opportunity to also clean up the past legacy issues. So I think for future conferences, Anne, I think we could have a really great discussion of each puzzle piece, Good SAM being one. Jason, you mentioned a project now with a PRP, which is different than Good SAM. We've got BFP, which is different from Good SAM. We've got funding. So I just want to make sure that everyone understands what those puzzle pieces are, particularly because now back in Washington, DC, we have an administration talking about the need for minerals, critical minerals, other minerals for energy transformation, for solar, for wind, for electrification, for EVs. So that is going to have to come from somewhere. I think the International Energy Agency said by 2040, we'll need 40 times the more minerals that we're using today. So AMLs provide an opportunity in that space, but that's separate and apart from what I believe to be true Good SAM and the Good SAM legislation that we've been working on. So I know that was a long-winded way of saying it, but there's a lot of issues kind of overlapping right now, and I just wanted to be clear where we are.
I think your points are well taken in that there's, in all of these summits that we have, there's an outgrowth of paths forward. So that's a great set of counsel, because these 4 years ago, we weren't talking about these various partnerships. So the good work that Trout Unlimited and other conservation groups are doing, like the Sierra Fund and Carrie's group and others, have shown a light on the improvements that we're seeing and the fact that we can get these done. And it's brought a broader coalition of stakeholders together to more succinctly and maybe more collectively make better improvements. And that includes state agencies, that includes federal agencies, it includes the trade associations, the industry itself, conservation groups, tribes, and my point being that as we've progressed these AML summits, we've illustrated the benefit of expanding the stakeholder participation and collaborations, because then the outcomes are so much broader and more inclusive and actually just better.
Yep.
You had a final
point we have a few minutes left.
Yeah.
I want to ask the question we've asked repeatedly in these summits. So some of you will have heard this before, but I kind of wanted to start maybe with Jason, if you could make some comments, because I saw your very last slide. And it asked that question: how clean is clean enough? We talk about this, and obviously that you could throw a lot of money if you had it available to completely fix the problem, maybe in some cases. Others probably not. No matter how much money you threw at it, you'd never get 100%. So I know this is a question we've raised at, I think, every one of these summits. And you commented on metrics that you've been using for determining effectiveness with monitoring. So that's my question, and not just, we'll start with the panel. Maybe Jason, you could first comment and then open it up to everybody else. I think it's time to have that conversation again. How clean is clean enough? How do we know when we can say, okay, this is one we'll actually go and tell people about?
Well, that's a tough one, but I think a lot of it traces back to what you define as your original work plan goals, is what you proposed in the initial phases of the project that you're going to do to try to quantify, and then getting down into the nuts and bolts after the project's completed to do so. I think that's what I said. As an industry, we are so quick to jump to the next project, and I think that there's not as much emphasis that happens on some of those BMP effectiveness measures, and it was brought up in the earlier panel on, like what the depth of contamination in a cap, and like knowing what that is and how it changes over time, and trying to quantify that. And I think that's why there's been this push with the state of Colorado and Division of Reclamation, Mining, and Safety to really look at some of those things and figure out what some of those measures are that are successful, and being able to better define and recommend how those might be used at a site in the future. And I mean, yeah, but it really goes back to work plan objectives and tying those together, and making sure in the beginning of the project, you're able to define what you're trying to achieve, and then reporting on it at the end. And that's kind of how we've done a lot of our work.
So, and just to cap that off, earlier you indicated that you use the EPA guidelines, so you have the federal engagement on it, and then yet you're working very closely from the state perspective, because their guidelines are going to be more specific to the state. So that dual marriage has been very helpful in advancing at least your BMPs and your parameters and your results.
I think that's a good point too, Ann, because depending on who the agency is you're working with, or whether it's a Section 319 non-point source project, you're going to be looking at TMDLs and loading and load reductions and things like that. So those are also going to define like what, your measurable results are. And then, EPA, it's going to be your own animal whenever you develop your work plan with them. So yeah, there's multiple aspects to look at that.
So I would throw one thing here, and this is the monkey in the room on a lot of things when you talk about how clean is clean enough, Jeff. The solution to the solution cannot be worse than the problem. So a lot of times we're thinking about just the direct, and Paul, you touched on this a little bit. We're trying to solve complex problems here, but sometimes when we look at our solution, and all of the indirect and the induced effects and the activities that come from that, we're creating more of a problem to that. So one of the things that we did, and not to, bring it back to the company sales pitch here, when we looked at reactivating this project, is how do we produce a pound of copper, Arizona's first pound of copper, for net carbon zero? How do we get there? And it's not just our direct footprint things like where we're getting our power, where we're sourcing our vehicles, how all that stuff goes in, but all of the downstream effects to it. We want the solution to this problem to be a solution, not to be something that's creating other residuals.
I think you need to put biochar back in your pit and use it as a repository.
I like it.
What do you think, Carrie?
Open for that.
Yeah, no regret solutions. I'm all about it.
Oh, sorry. Go ahead, Carrie. Then I have a couple of comments from the.
No, just reiterating the point that one of the benefits of working with biochar is that you're not going to do any harm. It itself will not make things worse.
Thank you. Agree with the comment. The key point is education. So thank you for that. And then a subsequent comment was, I'll distill it, is where do you start? Because that's on a local, regional, national level, that's pretty expansive and needs a real PR process. I think I've got to reach out to Carrie because biochar, I'm a big fan. And we even use it in biochemical reactors. It's an interesting little amendment that increases the efficiency. But beyond that, I think when Colorado first embraced the recreational marijuana industry, the marijuana growers found that biochar was a wonderful soil amendment, because what it did is it locked up the nutrients. You could water the hell out of a particular marijuana plant, and the nitrogen that you added was locked up in that biochar, and the plant would just pull it off the biochar as much as it needed, and it just made the marijuana industry so much more efficient. And for a while you couldn't find biochar. I think that situation has changed, but still, I just want to.
Thanks, Jim. That actually means a lot that you're into it. I really respect the work that you've done on all these bioremediation components. But I want to just emphasize that the Forest Service has been really interested in making sure that we're using a woody feedstock, that they know where it came from, and that it's being made at these rather low temperatures. And it's heated up slowly, and it's done in one of these, state-of-the-art plants. The one that we're getting the biochar from is actually in Oregon. The U.S. Endowment built this plant for $23 million. And so it has all of the controls and bells and whistles. And I don't think it will always be that way, but it is nice to start with a product that's very standardized for these test plot components. Biochar can be made very cheaply, in your backyard by stopping wood from burning before it turns to ash and pulverizing it and using it. And it's an agricultural amendment that's been around for thousands and thousands of years. So we're in this, like, how do you characterize the biochar that you're using to make sure that you are using the best that you can for the water quality needs that you have. And
if you're going to put something everywhere, for example, you're not putting something that's been made with municipal waste that could have other pollutants in it. So just a note on biochar, it's a bit more sophisticated of a process than I got a chance to present on. And if you want to talk more about that, I'm sure I would learn a lot from you.
You guys can have a biochar summit someday, Carrie. I do have a quick question, Carrie, I got to ask you at the risk of having a long discussion on biochar. I mean, I understand that they're actually manufacturing it, people are making it, but I mean, they figured that out from natural processes, right?
Yes.
So forest fires must generate a certain amount of biochar, right? Well, after the Dixie fire, Carrie, you must have about 1 million acres of biochar resource up there in Northern California right now, right?
Well, it's really a good question, and it just depends on the intensity that the burn. So unfortunately, the sites I visited have burned so intensely that you're standing on ash and these water repellent soils that actually aren't great or representative of what biochar could do. So that's what makes these kinds of fires we're having now, the catastrophic wildfires, so uniquely damaging, whereas cultural burns or prescribed fires are low intensity and more frequent, and they would likely have these benefits that you're referring to.
True, but in those fires, not all of it is, I mean, there are parts of it or margins where you would actually see this. It's not all high intensity fire.
Understood. Yes, biochar at scale is happening.
Oh, you want the grass fires?
Yeah. You want Arizona grass fires. You don't want Dixie fires.
Or
like you want low burn severity.
Or understory in forests.
No, because Dixie fire was like high burn severity, which sterilizes the soil.
Oh, okay.
So yeah, you want low.
Dixie was ugly.
It's a little bear terminology for you.
For those of you.
BAER, not Smoky Bear.
Yeah. For those of you who don't know, the Dixie fire was the big one in California last year that burned almost 1 million acres. It was pretty horrific.
I feel like this session has been a success because we've been able to tie a lot of the different elements back to cannabis.
Yeah, we can have a 420 discussion later. Okay.
I would just like to emphasize to everyone that when we go back to talking about how clean is clean enough, your stakeholders in your communities may have a completely different idea of what you're trying to achieve. And I'm telling my students and trying to teach them that definitions are really important. You all have got to define a lot of what you're doing to your communities, because your communities do not understand when you're saying you're coming in to clean up something, they expect it to go away and that they're now going to have fish and water. But if the fish were never in the river, you're not going to really be able to achieve that. So it's really important to spend a lot of time at the beginning with your communities and throughout the whole process so that they understand, especially your community leaders, that you're not always going to make it to what they think they're going to want it, that there are limitations to what you can do, and make sure that you let them know those limitations. I often get that feedback coming after some of these projects are done. People come to me and say, well, why didn't they do this, this, or this? And so you need to really spend time educating and doing that. We get tied up in our work, but you've got to tell at a 5th grade level is what we often use, is that you've got to get it so that if a 5th grader can understand it, then you probably have most of your community understanding it.
So Tanya, is that how you approach Congress? Yeah, okay.
Do we really need to avoid?
Well, no, keep it at least at a 5th grade level. Actually, I do have a question for Tani related to this. Tani, I know that early on when we were looking at Good SAM legislation, that was sort of a sticking point because there were some people who were advocating, oh, you got to meet in-stream EPA standards or, soil cleanup standards or something like that. But I'll be honest with you, I don't know where we landed on that in the Good SAM bill.
In the bill, it's partial or complete, and we describe it as measurable progress towards meeting water quality standards or site-specific soil quality, essentially. So we recognize that the way that the Clean Water Act and CERCLA with ARRs are set up to meet strict water quality standards that would reduce to probably 0 the number of projects that would be done. So recognizing that some improvement is better than none, and it will be improved above the baseline. So going back to Jason's comment, it's in your sort of application to the federal government what you intend to improve, and they will approve that or not.
Which gets back to the whole thing about engaging with everybody, all of the stakeholders, so that they understand what's going on. Well, that brings us to lunch.